Hello and welcome to another Ginger Mathematician video. I've had a lot of requests for this to do an all of IGCSE Transformations. And this topic is really one of the easier topics once you've got a good understanding on the IGCSE course, and this can be marks in the bag, usually on a paper 4. Right, let's get started. So we have a question here from an up-to-date 2022 paper. Now, the first thing we need to do, and this is very, very common, is to describe a transformation. And we want to do a single transformation. So in one movement or one action, we want to go from one place to another. And the first one we want to do here is triangle A to B. So we want to go from A to B. Now, the first thing to notice is, has there been any sort of change to the shape? And notice the shape looks exactly the same at A as it does at B. So if it's just a movement of the shape, then it's going to be a translation. And in order to get all the marks, you do need to use these words. Things like translation, enlargement, rotation, and so on. So that gives our first mark, our translation. And whenever we do a translation, we need to write down a vector. Now let's explain what numbers go in the vector. So the top number will represent going left or right, whereas the bottom number will say whether it's going up or down. So the top number, left or right, if it's negative, it's going to go left. If it's positive, it goes right. And for the bottom number, if it goes up, it's positive. If it goes down, it's negative. So we're going from A to B, so that's really important. And we compare what's called a corresponding point. So the same point on both shapes. So let's now consider what we do to go from A to B. So to go from A to B, we need to go 1 to the left, and then we need to go 1, 2, 3, 4 upwards. So we go 1 to the left and then 4 upwards. And if you're unsure in the exam, again, you can check another point on your shape. So this would also be 1 to the left and 1, 2, 3, 4 upwards. So if we actually want to write this as a vector, remember going 1 to the left, so that's going to be -1. If it was 1 to the right, we'd put +1. And we're going 4 upwards. So this number here will be 4. You will only get the 2 marks if you put translation for 1 mark and then that vector -1, 4, representing 1 to the left and 4 upwards. Now, our question B is a bit trickier, going from triangle A to triangle C. So if we look at triangle A to triangle C, we'll notice the shape is facing this direction, and then we're turning the shape, so this point part ends up downwards. Now, if we're getting a turning effect here, then we're going to have what's called a rotation. So you must use that word to get the first of the 3 marks. And in order to rotate, we need to say how much it's rotating by. Notice we're going a quarter turn. So we were facing west. Now we are facing south. So that's going to be 90 degrees. So we don't tend to write quarter turn. We usually say 90 degrees. And let's think about direction here. So we're going in this direction from A to C. So is that clockwise or is that anti-clockwise? We're going against the clock. So that's going to be anti-clockwise. You may know that as counterclockwise as well. So those are the 2 easy marks to get here. The rotation, make sure you write that. And then 90 degrees anti-clockwise. Now we need to think the other part, which is around what point, so our so-called center of rotation. So where are we rotating around? And this is where students often find this very difficult to identify this. Now, if you're used to tracing paper, then do check out the video above, because I do go through the tracing paper method of doing that. I actually do a quick poll to see what you do. Overwhelmingly, you do use tracing paper, but I'm going to use a different method here to find this center of rotation, which is going to use some coordinate geometry, which is a useful topic as well. So how do we do this? Well, we find points are corresponding. So this point here, the right angle here, corresponds to the right angle there. And what I'm going to do here is just draw a dotted line between them. So I'm just going to draw a dotted line going all the way through. Now notice that we go 1 down and then we go 7 across. So if we find the midpoint of this, so we find halfway between it, then if we're going 7 across, then this is going to be our midpoint here. You can probably identify that as well in order to see what's going on. And essentially what we've done there is we've gone half downwards and then we've gone 3.5 across. Now again, if you don't like this method, it's absolutely fine. You can always use tracing paper. And what I'm going to do here is draw what's called a perpendicular line. So a line at right angles here. So if I do this in green, I'm going to go half across. So that should be a half there. Half across and then 3.5 upwards. So 1, half, 1, 2, 3. And I can go in both directions. So I can go here and then go half, 1, 2, 3. And then I'm going to draw in my perpendicular bisector, like this. So notice at the moment I haven't identified where this rotation point is, but it's going to be somewhere along this line. Of course, we could expand this line all the way up. And we're going to do exactly the same process here to another coordinate that we have. So if we do this in red, well, we can take the top coordinate here. So these are the corresponding points. And we do the same process. So here we go 2 down and we go 6 across. So this line is going to go through here. And then this is our midpoint. You can probably spot that if you have a look at that. And again, we do the same procedure in black like we did before. So here we go 1 down and 3 across. So we want to go 1 across and 3 up or down in the other direction. So we go 1 across and then 3 up. Again, we can do this in both directions. And then this gives us the perpendicular bisector at this point. So go like this. And what we're looking for here is where the green line and the black line actually cross. So this is one way you can actually identify your rotation point without actually using tracing paper. So this will be our point, and this is the point here, 2, 1. So we need to write that in as our third bit of information. I will do some more practice on that particular skill because I know it's something that students find quite difficult. Now, on to part 2 here. We need to draw the image of triangle A after the reflection in the line y equals 2. Now, I'm just going to clear the screen so we've got a bit of room to work with. So we're going to reflect the line, the shape A in the line y equals 2. So we'll check this. Now, wherever you see a y equals line, this is going to be a horizontal line. Okay, if it's x equals, it'll be a vertical line. So we go y equals 2. So I'm going to draw a dotted line all the way across. And this makes our reflection a bit easier because what we do is we take this point, for example, and we'll take all 3 points eventually. And we see how close it is to the reflection line. So this is 1, 2, 3 away. So we need to go 3 in the other direction from the reflection line. Again, you can use tracing paper on this too. So 1, 2, 3. So that's going to be this point here. Let's do this in a different color, green. So how far is this from the reflection line? Well, 1, 2, 3, 4. So we need to go 1, 2, 3, and 4 to this point. And we do the same with the last point. Again, once you spot this and understand the method here, you can do this after 1 point. So here we go 1, 2, 3, 4. So we need to go 1, 2, 3, 4. So that's going to be our last point, and that is going to be our reflected shape, which I'll do in red. So this shape has been reflected to here. I'm usually going to just call that A dash to indicate it's the image. And that is my answer there. And on to the second part, which is always a trickier one, again, more the AA star component here, is when we do an enlargement by a negative scale factor. So this time we're going to enlarge by a scale factor of -2. So to give myself a little bit of room like I did last time, I'm just going to clear the screen so we can look at this in more detail. Okay, so first of all, we identify the center point. So that's going to be -1, 1, so -1 along and here. So this is going to be our center of enlargement. And let's now go through the process for -2. Now, if it's +2, then we'll be going downwards. So this shape will be getting bigger going downwards. But because it's -2, we're going to go through that point and then come out the other side. Now, let's actually see what that looks like. So again, we take corresponding points in our shape, and then we look at how much we go across and up to get to the enlargement point. So here we go 1 along and 2 upwards, like so. So what we're going to do, because we've got a scale factor of -2, we want to double this going in the same direction. So here we want to go 2 along, because this was 1, so we times that by 2, and we go 4 upwards. So 1, 2, 3, 4. So we get our first point. This point is transformed through the enlargement point and comes out the other side. Again, we can also draw this in as a dotted line to see how that happened. And then we're going to take another point here. So let's take in purple this time, this point. So how do we get to that red rotation point? Well, we go 1 along, and this time we go 3 upwards. So here we then go 2 along, the same as we did before, but this time 3 times 2 is 6. So then we go 6 upwards. So that's 4, and then we're going to go 5 and 6. So that's our point there. And let's take the last point on our shape. Again, at this point you might have a good idea of where it's going to be. So if we take this one here, how do we get to our rotation point? Well, we're going to go 4 along, and we're going to go 3 upwards. So because we got a scale factor of -2, we're going to do 4 times 2, which is 8. So we go 8 along. So it's 2, 3, 4, 5, 6, 7, 8. And then we're going to go 6 upwards. So 1, 2, 3, 4, 5, 6. Getting our last point of the shape there. So if we join those up, we can then see we've got our enlarged shape. We also have this kind of rotation effect, which is quite normal for a negative enlargement, which I'm going to also indicate here as a dash. Now you can do a double check on this. If you look at this side here, now this side has got a length of 3, so this length here should have a length of 6, which it does. So I'm using this also to double check that I do have an enlargement of 2, and a -2 just identifies exactly where it's going to be on my grid. Okay, so you can check the answers there. So if you take that last question, we've got 151777, 151777. That's all good. And again, you can check the answers for the other parts here as well. Okay, and moving on to another question. So we've got our question 2a here. So we've got our grid, which we're going to work on. And we're going to go through the following questions. So the first thing we need to do is draw the image of triangle T after a reflection in the line y equals x. So what does the line y equals x look like? Well, the coordinates have to be the same. So if we take this grid, for example, then 1 and 1. Y has to be the same as x. 2 and 2, 3 and 3. And also for the negatives as well. So -1 and -2 and 2, -3 and 3, -4 and 4. And we are reflecting triangle T. So we're focusing on that. So I'm just going to draw in this line just so we've got something to work with here. And when you have a diagonal line, one of the best strategies you can actually do is when you're in the exam, actually turn your page to make it a horizontal or vertical line, because it will make this next process much easier. So what we're going to do is we're going to take each corresponding point and then pop it over. So if we do that, we've got this point here, and we always want to meet the reflection line here perpendicular. So what do I mean by that? Well, if I take this diagonal like so, notice that this forms a right angle. So you know you are reflecting that line correctly. So we've got 1, 2, 3 diagonal, so we need to go 1, 2, 3 diagonal in the other direction. So 1, 2, 3, so that point comes to there. And we do the same process on each of these coordinates. So let's take this one here. Again, we want to go diagonal. So we go diagonal, 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 until we get to the reflection line. So let's see how many that is. That's 1, 2, 3, 4, 5, 6. So we go 6 again. So we go 1, 2, 3, 4, 5, 6. And then just to make sure we're doing everything correctly here, always take your time. we're going to do exactly the same process here with this green point. So we've got 1, 2, 3, 4, 5, 6, 7, and then we do 7 again. So we go 1, 2, 3, 4, 5, 6, 7. Almost therapeutic when you're doing this, yeah, particularly all the different colors. And now I'm just going to put my shape into red so I connect up all these points to give myself the triangle that I'm looking for. Again, I'm going to call this T dash to indicate that this is the image that I was looking for in this question. If you check the mark scheme, you see you get 2 minus 1, 2 minus 4, and 3 minus 4, which lines up with what we got there. Okay, and on to part 2 here. So now we're going to draw the image of triangle T after a translation by the vector minus 1, 3. So notice they can ask these kind of questions in different ways. They can ask you to describe or actually do the transformation yourself. Remember, the top number indicates left or right. Because it's a negative, we are going to go 1 left. And the bottom number indicates up or down. Because this is positive, we're going to go 3 up. So we're going to take triangle T, and we're going to move it 1 left and then 3 up. Okay, I've got some space in my diagram, so that's fine. So let's take any point here. So let's take this point, and we are going to go 1 left and 3 up. Notice the coordinate grid is slightly different here. So 1 will actually be these 2 squares. So this is 1 left, and then 3 up will be 1, 2, and 3. Now, if you get confident with this kind of question, what you can actually do here is once you've got one of the points, you can actually draw in the rest. Remember, with a translation, there won't be any change to this particular shape. So this is still going to go up by 1. This is still going to go across by 3. So we've got 1, 2, 3. And then we can draw that in. Again, I'm going to label that T dash to indicate that I've translated the shape. So that's a quicker way of doing this kind of question when you're a bit more confident. But if you're not, you can do each coordinate individually, translate it, and then you know you've got the right answer. So we've got our minus 5, 6, which is the one at the top. And then we've got minus 2, 5 and minus 5, 5, which are these two here. And now we need to describe the single transformation that maps triangle T onto triangle A. So again, we want to go from T to A in this case. I'm going to wipe off the board so we've got a bit of space to find this either reflection or rotation. Okay, so hopefully I caught you out there. It actually isn't a reflection or a rotation. Now, how do I know this? Well, one thing you should always check is the length of the sides. So the length of this side is 2, whereas the length of this side is not exactly the same triangle. This is actually 3. So the way that we actually find out the scale factor is just simply do big divided by small, because we're going from T to A. So the scale factor is going to be 3 over 2, or equal to 1.5. So actually in this case, we don't have a rotation or reflection, we actually have an enlargement. So that is going to be with a scale factor of 1.5. However, it doesn't necessarily have to be positive 1.5. If it was, then it would be coming outwards probably, and therefore it would be a positive enlargement. Because we have this kind of reflection or rotation idea, it needs to be negative. So we've actually got a negative enlargement here of minus 1.5. So these are two things we can write in. We have an enlargement first of all, and this is with a scale factor of negative 1.5. However, just like with a rotation, we need to find the center of it. So in this case, the center of enlargement. And the way that we do this is slightly easier than if we actually had a rotation. So what we do is find corresponding points of our shape here. So notice that we've got the right angle here and the right angle here. And what we're going to do is connect those up together. So if we do that, we are going from minus 4 to 10, and then we are going from 2 to 4.5. So we want to try and draw this with a ruler as accurate as possible. I don't have a ruler in this case, so what I will do to make my life a bit easier is actually mark in the midpoint. so the midpoint between them. So we know it's going to be at 2. So it's going to be at 1, because that's halfway between -4 and 6. And if we look at this scale, so between 2 and 4.5, that's a little bit more tricky, because that's going to be a gap of 2.5. So we're actually looking for then 1.25 in between. So that's going to be at 3.25. So that just gives me a bit of guidance when I actually draw this in. So let's now draw in this particular line. Try and make this as straight as possible, because otherwise it's going to be hard to identify the center of enlargement. Here we have something slightly easier to work with. So if we take those 2 points here between -1 and 1.5, again we are going to get a gap here, or a slight gap of 1.5, 2.5. So again we want that 1.25 in between. So that's going to be at 0, 2.25. And if we're working upwards, so between, it's going to be the same as before, so 2 and 5. So it'll be at the same height. So what we can do here is we can pop that in, and then we're going to draw in our dotted line like so. And now we can do the same with the very last point here. So we've got this point, and this corresponds, if you think about the rotation effect, for this point, and so we pop that in like so. Now the key thing is to do this with a ruler, because a clear point then comes in terms of our rotation point. I think we can see here that most of the lines here do cross here. If you do this more accurately, we will get this, and so this is going to be our negative enlargement point, which is at 0, 3. So we pop that in and just say the center of enlargement is at 0, 3. Just point about the mark scheme here, so you get B1 for each here, so 1 for enlargement. You don't have to put scale factor, but I think it's good practice, of -1.5, and then the center of 0, 3. This shows the disadvantage of doing this without a ruler. If you do that, you can see the lines don't quite cross at 0, 3, and it becomes harder to actually find that rotation point. Sorry, that center of enlargement point. So make sure you do that at home and use a ruler. And now we've got a nice little twist here with similarity and scale factors to finish off. So quadrilateral P is enlarged by a scale factor of 1.2 to give quadrilateral Q. And we're told the area of quadrilateral P is 20 square centimeters. Calculate the area of quadrilateral Q. So even within a transformations question, they are really testing your knowledge of other areas of the course. Now, of course, we've got an area, so we actually want the area scale factor. And the area scale factor will be the one that we're given, but we need to square it. So if we square 1.2 squared, turn on the calculator, then we get the number of 1.44. This is where we have to be very careful. And now we want to find the area of quadrilateral Q. So to find the area of Q, we take the 20 that we got before, and then we times by 1.44. The biggest mistake students make on this kind of question is timesing by 1.2. Now if we do that on our calculator, this is a calculator paper, then we get our answer of 28.8, which I'll just pop in here for the 2 marks. Okay, so you can check your answers, so you can look at the mark scheme now in a bit more depth. Again, you get a method mark for identifying this idea of doing 1.2 all squared. If you're liking the content so far and the way that you're being presented with transformations, then do like the video. It's the best thing that you can do, and that helps it spread to more people and hopefully help them with their IGCSE exams as well. Okay, and on to actually a paper 2 question. So I do want to put some paper 2 comments in here as well. It's similar to something we've already looked at before. So describe fully the single transformation that maps triangle T onto P. Now the thing to watch out for in this question is T to P. So we're actually going from larger to smaller. This is something that students don't watch out for. So this has got a length of 2. This has a length of 1. Therefore, our scale factor is actually going to be 1/2 because we're going from bigger to smaller. So we've got a scale factor of a half, but you probably already know where I'm going with this. Because we have this rotation effect, it's going to be minus a half. So that's going to be one of the crucial factors. So we've got the enlargement here again, just like we saw in the previous question. This really shows you need to practice those negative enlargements on this course. So enlargement, and this is with a scale factor of negative a half. And now we need to find the center of enlargement. So that same process that we did in the previous question. And if you can master this, this is really giving you 3 marks, which are quite nice to get in the exam. Now remember the way that we do this, we take corresponding points of the shape, so the points that are the same on both shapes, and then connect them up. Now let's take our first one, so this point here corresponds to this point here. And this is a bit easier to deal with, so we can just connect these up. This goes across quite nicely in this case, one along and one upwards. Again, we can do the same with another point. Let's do this in green. So down here, and it's going to be with the right angle here. So in this case, we go 3 along and we go 6 up. So we want to go to 1.5, and we want to go 3 upwards, so up to 5. So we're going to join those up together. You might see where we're heading with this, like so. And if you're not entirely sure that this is the correct answer, you can always confirm that by looking at one of the other points as well. So if we take this very last point here, so if we take this one here, so 1, 2, and then this point here, here we go 9 along, and we go 6 up, so we want to go 4.5. There's our 4.5. 1 plus 4.5 is 5.5, and then we go up, so up to the same as what we did before here. And if we join those up, you'll notice we go through that same point that we're heading for, like so. So use that third point really to guarantee that you do have the correct center of enlargement in this case, which is equal to 4, 4. So we pop that in to make sure we get that 3rd mark. So you can check the mark scheme here. So enlargement, 1 mark, scale factor minus a half, we got that, 2nd mark, and then center is always the tricky one to get here, which is equal to 4, 4. So make sure you go through that really, really carefully. First thing we're going to do is translate triangle A with the vector -3, -5. So reminder what this means. So our top number tells us whether we go left or right. Because it's a negative number, we're going to go 3 left. And our bottom number tells us whether we go up or down. And because it's negative, we're going to go 5 down. So we take our triangle. I'm going to take a point on the triangle. I'm going to take this one here where the right angle is. And I'm going to do exactly that, follow the instructions. So I'm going to go 1, 2, 3, and then 1, 2, 3, 4, 5. So this point of my shape is translated to this coordinate here. Now if we check this, go 1, 2, 3, 4. I'm going to do the same thing. So 1, 2, 3, 4. We go 1 across, and just copying this shape, and then we join up to make our triangle. And it wants us to label this as B. So make sure you do follow the instructions of the question. It did ask us to label this particular image B, so make sure that you do that as well. And now it's asking us for the single transformation that maps triangle B onto triangle A. So what it's asking us is, how do we go from this triangle to this triangle here? So how do we do the opposite of what we just did? Well, let's have a think. It's still going to be a translation. So we're just moving the shape, and now we need to state what the vector is. Well, notice if we go back, well, we're essentially going to go 1, 2, 3 to the right, and 1, 2, 3, 4, 5 upwards. So it's exactly the same vector, but this time we make numbers positive. Because instead of going 3 left and 5 down, we want to go 3 right and 5 upwards. Notice it's a 2-mark question, so 2 pieces of information, 1 for translation and 1 for the correct vector. Okay, and on to question C, which is always difficult to do on a computer, but this actually is one of the easier kind of rotations to do. So you want to rotate triangle A through 90 degrees clockwise. So remember, clockwise is in this direction, about 0, 0. So we're going to rotate around this point. Now, as I always say in my videos, when it comes to rotations, use tracing paper. It will make your life easier. However, there is an alternative to doing this that doesn't go into IB maths, so that'd be good. I'm going to take one of the points on my triangle and I'm going to join it up with the center of rotation. Okay, a little bit, yeah, not quite straight, but it's you can see what's going on. And if we actually look at the gradient of this line, so when I say the gradient, I mean, okay, the change in y over the change in x. Hopefully we can see here that we are actually going downwards, so therefore the gradient 1 divided by 1, but it's going to be a negative. So the gradient of this line is equal to -1. So the way we can actually find the rotation point here is actually find a gradient of a line that's perpendicular to this. So what do I mean by this? Well, I want -1 times something is equal to -1. This is a fact you may have seen in school, that m1, m2 equals -1. And so I need a number that fits in that gap, and that number is going to be 1, because -1 times 1 is equal to -1. So I need to draw a line that's perpendicular to this, and it's got the same length. So this is actually quite straightforward. We can actually draw a line, a diagonal line, up to 4 like so. Notice that these 2 lines meet at a right angle, which is what has to happen in order for this to be true. Now from there, just like the previous question, we can actually draw our shape in. Now it's turned 90 degrees, so we know now that it's going to look like this using our reference point, and it's going to go across 4, so 1, 2, 3, 4, and then across, and that's going to be our shape C. So let me draw that in and give it a letter. So here we are, C. Again, I really highly recommend you do not use this method. I would use tracing paper every single time, but if you're looking for an alternative, this can also work as well. Okay, and the part D is we need to reflect triangle A in the line y equals x. So just a reminder that the line y equals x is in fact the line I've literally just drawn. So if I do this in a different color, this blue line is actually the line y equals x, because along this line, let's draw this in, all the x coordinates are equal to the y coordinates. Okay, so now we need to think how this actually reflects across. So we need to think about how we're going to draw this. Well, we take corresponding points. This is the way I tend to do it. So see this green line, it goes all the way actually to the rotation points and the reflection line, and then we just come out the other side. So we want the same length. So 1, 2, 3, 4. So this point will correspond to this point here. And essentially we do the same method with all the different points as well. And if we actually put this all together, we're going to get a shape. This point is going to reflect all the way down to here, 4 minus 5. And then this point here, if we go all the way diagonally across, is going to reflect across to 8 minus 5. So we get this shape here. And using that key coordinate to then tell me exactly where the shape needs to go. And so we get our shape here. So we've got 4 minus 4, 4 minus 5, and 8 minus 5 there. So this can be our shape D. So we call that D like so. And that's question D done. And then the last question wants us to do the single transformation that maps triangle C onto triangle D. So the question is, how do we go from this shape here to this shape here? Well, you'll notice it's the same distance away from the x-axis. Notice this is a gap of 4 here, and this is also a gap of 4 here. So our reflection line is actually going to be the x-axis. So if I draw this down a different color, lots of colors today. This is our reflection line. So now we need to write this in correct mathematical notation. We don't generally write the x-axis when we reflect. We want to write the proper name for it, and that is going to be the line y equals 0, because every coordinate on the x-axis has a y coordinate of 0. So for this part, 2 marks, so 1 mark for reflection, and then 1 mark for the line we're going to reflect in, which is y equals 0. Again, this question would have been so much easier for myself if I had some tracing paper, but if you want to work this out without tracing paper, this is the way to go. Right, check your answers, so you can have a look through exactly what I've done. So this comes directly from the Cambridge exam board, so you can check the calculations I've done. Okay, and question 2. So a very typical transformations question. This is something you really should revise if you want to excel at the paper 4. So let's go through this. So describe fully, first of all, the single transformation that maps triangle A onto triangle B. So it's a 2-mark question. Always use the amount of marks to guide how much detail that you need to put. The first thing we need to notice here is that going from A to B, we're just moving the shape essentially, which we call a translation. So you need to know these key words. So I'm going to write down translation, which essentially means moving the shape. And as soon as you talk about translation, you need to be thinking of vectors. So we're going to do translation by the vector, and then we're going to write how it's actually moved. We put this in bracket notation like so. The top number tells you how much it goes left or right. So let's work out what's happening here. So to go from A to B, I'm going to take a point here and match it up to a point over here. So we're going to go 1, 2, 3, 4. So we're going to go 4 to the right. So we put a +4 here. And if you're in the exam and not entirely sure, you can always check another point. So if we take this point and this point, for example, then we can check 1, 2, 3, 4 to make sure we've done it correctly. And notice that we're not going up or down with our triangle, so the number here is going to be 0. So we get a translation by vector 4, 0. 1 mark for translation, 1 mark for 4, 0. Our next part is we're going to take triangle A and we're going to reflect that in the line y equals, no subtitles, y equals minus x. So what we're going to do is we're going to take the original triangle here, the triangle A. Always read this carefully if they want you to do triangle B or triangle E, etc. And we're going to reflect that in the line y equals minus x. The first thing we need to remember is what does the line y equals minus x look like? So y equals x is this line going all the way up. So the line y equals minus x is the 45-degree line going in the opposite direction. So let me draw this in. So I'm going to try this. First time I've been using the pad, so let's see how straight this is. Not too bad. Probably needs a little bit of work. If you're not sure where this comes from, well, let's have a look here. When y is equal to minus 1, then x has to equal to positive 1, so that's true. So you can check coordinates here to make sure you've got the correct line, y equals minus x. And what we're going to do here is do a reflection. Now I'd highly recommend that you use tracing paper to do this. This is perfectly allowed on IGCSE. Without tracing paper, this is also fine as well. So let me choose a different pen colour. Let's go with magenta, why not? So we take a point on our triangle, we take the corresponding point that's perpendicular, so at a right angle to that point, and then we transfer it across to the other side. So we've gone 1 to the left and 1 down, so we need to go 1 to the left and 1 down. So this purple point here, we reflect it in this line, reflects over here. Again, use tracing paper, it will make your life much, much easier. Let's take another point. So let's do this in blue. So if I take this point here and I make a perpendicular line, so a line at 90 degrees to that blue point, notice there's a right angle here. I go 2 to the left and 2 down, so we go 2 to the left and 2 down, and then we get to this point here. Notice this should be the same length as the line over there. And let's do it for completeness. Let's see if we can get a different color. Let's go with
I don't want magenta. I've already used magenta. I want to use yellow. There we are. So we take this point here, we do the same analysis. This is a bit trickier because we're halfway in a box. So we're going to go from here to here. So you can see this is a right angle. We are going essentially 1.5 along and 1.5 down. So we need to do the same thing. And then we'll come to here. Again, tracing paper makes your life easier. Once you've done the 3 points, either using tracing paper or using the method I've done here, then you can just draw in the triangle like so. Not the best triangle in the world. We're going to label the image C. So make sure you label this for your examiner C so they know the triangle that you've actually drawn. That is probably the worst triangle I've ever drawn, but you can see the idea here. For part C, we're going to go back to this original triangle A, and we're going to rotate this 90 degrees clockwise. Remember, clockwise goes in this direction, following the clock, about the center 1 minus 1. Notice we're not using the origin, we're not using the center point here, we're using a different point, so we're going to be using this point here, 1 minus 1, which we're going to put in black. Again, use tracing paper, so put tracing paper over the shape, draw around it, mark in the center of rotation, and then spin it 90 degrees. However, we don't have access to such clever things here, so we're going to do this manually. So notice that in order to work out the rotation, we know it's roughly going to be over here because we're turning this direction. The way we would find this out, to keep it fairly straightforward, is that it's going to make a right angle with where the new point is going to be, and it's going to be the same distance as well. So this point here is going to be rotated to here. When I've got this reference point, then I can fill in the rest. So I know that it's going to look like this. Again, you can visualize that in your mind that this is coming around to here, but in order to know where it's going to be, which is the most important thing, you need to find a reference point. So you use this point to here. But again, use tracing paper, it will make your life much easier. We are going to label this D. So we've done this question, this question, and this question. And the reason we label it is exactly for this type of question down here, part D. Describe fully the single transformation that maps triangles C to D. So essentially we want to go from this triangle to this triangle here. Now the first thing to notice here is there's a reflection going on. So we need to write down then reflection. And it's a 2-mark question. I'm using that as a guide here. So we need to provide another bit of information, and that is the reflection line. So we're going to have a reflection in the line. Remember when I first taught GCSE and IGCSE, they're very fussy about the prepositions you used, but now they're fine, just say reflection in the line. And I think we can see here that the line is going to be this vertical line going all the way down. And we can check this at this point here is 2 away from the reflection line, and this is also 2, so we can use that as a check. Now let's think about how we identify this line. Well, if we take all the coordinates on this line, so this is 1, 5, this is 1, 4, if I go down the bottom, this is 1 minus 5, etc. What do all these coordinates have in common? And they all have an x equals 1 in common. That gives me the name of this line then of x is equal to 1. 1 mark for reflection, 1 mark for x equals 1. Now for the last part, I'm going to get rid of the pen because we need to be able to see what is going on. There we are, like magic. And what we're going to look at here is the single transformation that maps A to E, so going from this to this. And you first look at this and think, well, it's not quite an enlargement, because it's not in the same proportion. It's not a translation either, because it doesn't look the same, like A to B. So then we have to think, it's like an enlargement and it's kind of like a translation. What would be kind of in between? And that would be a stretch. Now make sure that you have learnt about stretches. This is something that often gets forgotten by IGCSE teachers. Make sure you know how to do stretches as well. Now this is a 3-mark question in comparison to these 2-mark questions, so we need 3 bits of information. So first of all, we have a stretch. The next thing that we need to work out is our stretch factor. Okay, so I'm going to put stretch by factor. And now let's have a look at this. So let's take corresponding sides. Well, this side is 1, and this side here, in comparison, is 2. So like an enlargement, we compare the sides and go, well, this is 1 and this is 2, so we must have a stretch then of factor 2. And the last part, which is probably the most trickiest part here, is actually working out what the stretch, where the stretch is actually occurring from. And we call this the invariant line or the invariant axis. Yeah. So I'm going to call this invariant line because you don't know whether it's an axis or not. And then we need to work out where it's being stretched from. So let me go through that nice and carefully. This is probably the hardest part of the question. The easiest way of doing this is a kind of trial and error basis. So, for example, if I take the x-axis, which is going to be our correct answer, but let me show you why that's the case. We look at corresponding points. So this point here and this point here of our shape. The distance from here to here is 1. Whereas if I take the distance from my supposed invariant axis and this point here, that is going to be 2. Now let me take another point. Let me take the top point of our triangle, this magenta. If I go from this point to this point, this is going to be 2. But if I go from this point here to all the way up to the top, this is 4. So you can see there is a consistent stretch going on from this particular line, and that's what we're looking for. Likewise, if I do this for completeness, from here to here is 1, whereas from here to here is going to be 2. So for every point in my triangle, there is a consistent stretch upwards. And if you find this consistency, then you know you found the correct line. So actually here we have an invariant axis, not an invariant line. So we're going to call this by invariant line the x-axis, which I'm going to write in purple because why not? So we get 1 mark for stretch, 1 mark for factor 2. Notice this is not an enlargement factor, it's a stretch factor, so I'm just writing factor. You usually don't lose a mark for this, but just be careful. And then our invariant line, so where the stretch is happening from, is the x-axis. Think of this as if you're putting your foot on the actual line and then you're stretching the shape upwards. That will give you a good idea of what is going on. So let me show you the mark scheme. So we've got a translation 4, 0. These are the coordinates of the triangle that I reflected and rotated. Reflection x equals 1. And then stretch, 1 mark, factor 2, or stretch factor 2. And the x-axis is our invariant line. Okay, I put invariant line, but as long as you've got invariant there, that is important. Quickly go through the exam review after this exam was done last year. It was well done by most candidates. Yeah, you do need to put translation, that's really important. You can't just put move, for example, or shift, not good enough. Most B, C and D were generally done correctly, and many students got the stretch as a type of transformation with scale factor 2, but finding that invariant line is that discriminator question between an A and an A star. So do make sure you know it.